Good day, students. Welcome to your chemistry class. In our last class, we looked at esters, and we said that esters are sweet-smelling compounds that are responsible for the fragrance and aroma of flowers, okay, and also fruits. So we made mention of the nomenclature of esters, how to name esters. That we start naming esters from the front. And I also made mention of it in the last class that the general molecular formula for esters is ROCOOR. This is the alkyl group, this is also alkyl group. And in naming them, we start from the front here. So depending on the number of carbon atom present, if it is 1 carbon, is met. If it's 2 carbon, 8. 3 carbon, pro. Okay? So if you have 2 carbon atoms here, it will be ethyl. Then from here, now the carbon here and this one now ethanoate or alkanoate, okay? Depending on the number of carbon atoms that are present. That is how. So this ROCOOR is the general formula of esters. And we've done all this in our previous class. In today's class, I want to consider a specific type of ester called ethyl ethanoate. So because this ethyl ethanoate, ethyl X is 2 carbon atoms. So the formula will be CH3 COO CH2 CH3. Because look at the formula on the board. This is the molecular formula. CH3C here. This there are 2 carbon atoms here, so it's ethanoate. This 1, 2 ethyl. I told you start the naming from the front. So ethyl ethanoate. That is general molecular. That is the molecular formula of ethyl ethanoate. While this one is the structural formula of ethyl ethanoate. Look at there are 3 hydrogen atoms attached to this carbon. You attach it here. You expand. You open it. This carbon double bonding oxygen. This oxygen. Then this oxygen just that way. You express it that way. So this is the structural formula of ethyl ethanoate. The next thing we're going to look at is laboratory preparation of ethyl ethanoate. How do we prepare it in the laboratory? All right, so we prepare ethyl ethanoate in the laboratory by the reaction of ethanoic acid with ethanol. When ethanoic acid reacts or combines with ethanol, it forms ethyl ethanoate, and water is given out according to the reaction. Look at this reaction here. You see this ethanol reacting with ethanoic acid in the presence of mineral acid. The proton here is from mineral acid, and that will give you ethyl ethanoate and water. All right. Now look at the nature of the reaction. In this reaction here, if you break this bond here this way, I've shown you in our last video how bond cleavage occurs and how esters are formed. If you break this bond here, here will be plus and here will be minus. If you break this bond here, here will be minus and here will be plus. Based on the basis of reaction mechanism, there will be exchange of charge. The positive here will go to the negative here, while the negative here will go to the positive here, and that will lead to the formation of the product. So here you have CH3COO, CH3COO, okay, being minus. Now it will pick the negative, the positive here, which is CH3CH2. So you have CH2CH3, okay, this way. Then the plus here will go to the minus here, and that gives you water. So that is how ethyl ethanoate is prepared in the laboratory. The next is physical properties of ethyl ethanoates. Number 1, ethyl ethanoates are colorless liquid. They are volatile, and then they dissolve sparingly in water, but dissolve readily in organic solvents such as chloroform, esters, benzene, hexane, and the rest of them. Ethyl ethanoate also has a boiling point of 75 degrees Celsius. Chemical properties. One of the chemical properties of ethyl ethanoate is hydrolysis. When we talk the word hydrolysis, what does it mean? Hydro means water. Then lysis means breaking down, degradation. So the use of water to break down a substance is called hydrolysis. So the use of water to cleave, to break down ethyl ethanoate to form various products is called hydrolysis. And when you subject ethyl ethanoate to hydrolysis, it gives you ethanoic acid and ethanol. Remember, these are the components that were used for its synthesis. So when you use water to break the bond, it leads to the formation of those components. Okay? So look at the reaction here. in the hydrolysis, you have CH3, COO, CH2, CH3. This is ethyl ethanoate. Now combine it with water. If you break this bond here, this is H, this is O. If you break this bond in this way, here will be what? Minus, and here will be plus. Now, coming this way, you break this bond this way, here will be minus, and here will be what? Plus. With plus, okay? So based on reaction mechanism, the positive here will go to the negative here, while the negative here will go to the positive here. So you have CH3, COO, and this minus will be attached to this one. That gives you this ethanoic acid. And then you have CH3, CH2 being plus. It will pick this minus to give you CH3, CH2O, which is what? Ethanol. So the product of hydrolysis of ethyl ethanoate is ethanoic acid and ethanol. Now, when we do the hydrolysis in the presence of alkali like sodium hydroxide, it leads to the formation of sodium ethanoate and water. Look at the reaction here. If you break this bond here, now, here will be minus, here will be plus. You break this bond this way, here will be plus, and here will be minus. So the same mechanism. The minus here will go to the plus here, while the plus will go to this minus, and that will give you this product, which is sodium ethanoate and ethanol. So that is hydrolysis of ethyl ethanoate. Next is reaction with ammonia. Reaction with ammonia gas. When ethyl ethanoate reacts with ammonia gas, it gives you ethanamide and ethanol. Look at the reaction here. This ammonia, you break the bond here. This ammonia, you break the bond here. Here will be plus and here will be minus. Okay. Now, coming this way, you break this bond here. You break this bond here. Here will be plus. Here will be minus, and here will be plus. So you now have this CH3CO being minus, will be plus. We'll pick this minus, which is NH2, which is this. That leads to the formation of ethanamide, and then this CH3, CH2O minus will now pick this plus to give you ethanol. So the reaction of ethyl ethanoate with ammonia will lead to the formation of ethanamide and ethanol. And lastly, reduction reaction. When you use 4 moles of hydrogen to react with ethyl ethanoate, you're going to form 2 molecules of ethanol. Now, in this reaction here, you see that you have CH2 here, you have C here. If you break this bond this way, one hydrogen from here will be attached here, and then one hydrogen from here will be attached to this other way. Then the remaining 2 hydrogen will be attached to this guy, to this carbon here, to give you CH3CH2OH. And this guy now becomes CH3CH2O. Then one hydrogen attached will give you H. This is 2 moles of ethanol. So this is how we obtain the 2 molecules of ethanol that will form here. So that is the chemical properties of ethyl ethanoate. Now, some of the uses of ethyl ethanoate. Ethyl ethanoate are actually used as solvents for cellulose nitrate and quick drying substances like paint, nail varnishes, and also adhesive. It is common. The common known thinner is a mixture of ester, including pentyl ethanoate. Now, it's important for you to know the most important one, that ethyl ethanoate, generally esters, are used in perfume industries as fragrance. They are used in production of perfume, production of paint, and then production of perfume, production of simply put, they are used in cosmetic industry and in food flavoring. Thank you very much for being in today's class. Finally, assignments. Number 1, using equation only, show the laboratory preparation of propyl ethanoate. 2, give the ionic nomenclature of the following: CH3 to CHCOOH, CH3, CH2, CH2, COO, CH2, CH2, CH3, and finally CH3, CH2, open close bracket 3, CO2, CH2, open close bracket 2, then CH3. Thank you and God bless you.